Hey everyone, let's continue with 7.3. This is page 2. It's more finding exact values, but this one looks a little more complicated. Really what you want to do with these is notice the structure. You've got cosine, cosine minus sine, sine. So try to match that with one of the identities from page 1. So I'm looking for cosine, cosine minus sine, sine. If I look back up there, I see right there matches. So I'm going to use this identity in reverse. I'm going to write it as that. I just have to identify the A and the B, which are the angles. Right? So this one's a cosine, A plus B. So if I go back down, this is just going to equal cosine of A plus B. Okay, and that's equal to the cosine. If I add those together, that's 180 degrees. And 180 is on the unit circle, so I can take this a step further. Cosine of 180 is equal to -1 from the unit circle. And that's it, okay? So number 5, again, we're trying to match that structure with an identity. So I see I have on this one, cosine sine minus sine cosine. Okay, that seems like there should be something. This one's close. It's sine cosine minus cosine sine. It's the sine of A minus B. So I'm going to use that one. I just have to do a little adjustment on the expression first to get it sine cosine, cosine sine with the angles reversed, right? So if I just flip-flop this around, which is legal, sine 160 cosine 40, right? Because multiplication is commutative, I can flip those around. And then same with those, cosine 160 sine 40. That's the same thing. And now it matches the identity precisely. So I can use that identity. It's the sine of A minus B, 160 minus 40. And 160 minus 40 is 120. So sine 120. If that angle is not on the unit circle, I have to stop, but 120 is on the unit circle, so I can continue. So if I look up my unit circle, that's in quadrant 2. The angle 120 you'll see as a positive square root of 3 over 2. Okay, sine of 120, back from chapter 5, is equal to root 3 over 2, positive. Okay, continuing on, looks like we have another one that's sine, cosine, cosine, sine with the angles reversed, but it's a plus. So this is going to be equal to the sine of the angles added together by that identity above on the first page. Okay. And since we're after the exact value here, if you prefer, pi over 3 is 60 degrees. Pi over 2 is 90 degrees. So you can just do this in degree mode. That's the sine of 150, right? Which by the unit circle, you'll see that that's equal to 1/2. Okay. How about a tangent one? Okay, so I got a subtraction up top and an addition down below. So look back at your identities. Subtraction up top and addition down below. There it is. It's tangent of A minus B. All right. So I'm going to do this is equal to tangent of 62 minus 17. And 62 minus 17 is 45. And I can do that one more step because it's on the unit circle, 45 degrees. That's where x and y are equal. So the tangent is 1. Okay, so all of that is equal to 1. I suppose you can plug all that into your calculator at once for a check. Plug that in, see if you get 1. As long as you're in degree mode in your calculator, it should give you 1. Okay. All right. For these next 3 on this page, it says write as a single function of theta. So again, we're going to apply the identity and then see if we can simplify it. So think of this as A plus B. Right? And then for the cosine of a plus b, it's cosine of the first angle, cosine of the second angle, minus sine of each one. So that's that very first identity on page 1. Okay. And then now I have values on the unit circle. Cosine of 270 down at the bottom of that unit circle, that's equal to 0 times cosine theta. And sine of 270, that's -1. Okay, so 0 times cosine is 0. Negative and negative is positive. 1 times sine is sine. And then 0 plus sine is just equal to the sine. So this reduces down to sine theta. Okay. The next one, let's see, we have sine A minus B. So that's going to be sine A cosine B minus cosine A sine B. Right. That structure of that third identity on page 1, or fourth one, it's fourth one down, sine A minus B. All right. Let's see, sine theta, we can't change it, but cosine 90 is unit circle. Cosine of 90 is 0. Okay. Cosine theta, and then sine 90 is 1. All right, sine theta times 0 is 0. Cosine theta times 1 is cosine theta. And 0 minus cosine theta would be a negative cosine theta. And that's it. Okay, finally we have a tangent, tangent A minus B. So again, what I'm referring to when I do these, all the way back up, that's that one, right? Tangent A minus B. So I'm doing this expression, all right? Minus on top, plus down below. So this is equal to tangent theta minus tangent pi over 1 plus tangent theta times tangent pi. And now unit circle. Tangent theta, we just got to leave it because that's a variable. Tangent pi, well at pi, the x value is -1 and the y value is 0, and tangent is y over x, right? So that would be equal to 0. Okay, and then we have the bottom 1 plus tangent theta times tangent pi again is 0. Okay, and so up top we have tan theta, and on the bottom we have 1 plus tangent theta times 0 is 0. So that's just tangent theta over 1, just equals tan theta. Okay. Which makes sense because the period of tangent is pi. So if you subtract pi from the angle, you're back at the same spot. Okay. Okay, so there you have it. That's page 2. I'm going to stop there. I'm doing one video for each page on this handout. If you have any questions, send them my way. I hope that was helpful. Talk to you later.